Hey everybody, so I really wanted to get this video out, but my screen recording setup is not having it today. So rather than wait, I'm going to keep this one a little shorter than I normally would, hit the important concepts, and provide the full step-by-step presentation with every single click linked in the description. You can pull it up and do it the entire lab at your own pace on your own machine. Think of this video as more of like a prelude of me walking you through what we're going to be building and why, and the slides is your actual instruction manual. So, what are we going to be building? Well, an Active Directory Homelab on your home Wi-Fi using free tools. Active Directory is how nearly every company in the entire world manages who can log into what, who has access to what, and what the password rules are. We are setting that up today from scratch, and honestly, it is one of the best things you can do and put on a resume if you're trying to get into IT or cybersecurity. So let's start with what you actually need to do this in terms of system requirements. As you can see here, not really much. Any computer from the last 5 or 6 years with at least 8 gigs of RAM, about 50 gigs of free space, and a Wi-Fi connection. Windows, Mac, Linux all work. The one thing that catches most people off guard though is virtualization. Sometimes it's automatically turned off in BIOS, but the slide above covers exactly what the fix is and it takes about 30 seconds. Also, want to be upfront. I wrote this assuming you have never touched a server before. So if you've never opened Active Directory, you're exactly who this presentation is for, and the slides spill out pretty much every click, so you're never guessing. Now, assuming that your machine checks out, let's talk about what you need to download. There are two things you need, and both are free. First is VirtualBox, which is software that lets you run a virtual machine, basically a fake computer inside your real one. You grab that from virtualbox.org, linked above, download it, install, default settings, put it to the side. Then you download Windows Server 2022 ISO. You can get this from Microsoft's Evaluation Center, linked above. It's a free 180-day trial, no credit card, no catch. Now, it's going to take a little bit for both of those to download and start where you need them. Do it now, waiting, running. Okay, I assume you're done. Let's go. Now, every home network is a little different. Your router might hand out 192.168.1 addresses or 192.168.0 or 10.0.0. But it doesn't matter because the lab works exactly the same way. You just need to figure out your gateway, which is your router's IP, and pick a static IP for our server so that nothing else on your network is using. Something like .50. Now, we're using lab.local as our domain name. The slide shows you exactly how to find your numbers and you'll reference them through the entire lab. So once you have those written down, let me show you how it all fits together. The architecture is 3 pieces that all talk to each other. Your Wi-Fi router at the top handles internet and hands out IPs. The middle is DCO1, which is the domain controller VM that we're building. And it's going to run Active Directory with DNS. At the bottom, as you can see, is just our laptop running VirtualBox. The important concept here is bridged networking, which puts the VM directly on your Wi-Fi with a real IP address instead of hiding it behind VirtualBox on a fake private network. That matters because every machine in Active Directory needs to be able to find the domain controller directly. So with that picture in mind, let's start actually building. The slide has every click for creating the VM. So follow along with that. What you're really doing is carving out 4 gigs of RAM and a 50 gig virtual disk from your real machine and then giving it to the fake one. The 50 gig disk is supposed to be dynamically allocated, which really just means the files start small and only grows as the VM saves the data. So it just won't eat all of your space right away. Then what you're going to do is attach the Windows Server ISO, which is like putting a DVD in a drive so the VM has something to install from when it boots up. Once the VM itself is created, we need to fix the network setting before we start it. So we are still in the VM settings. You switch the network adapter from NAT to bridged. NAT is the default and it isolates the VM on a private network where nothing else on your Wi-Fi can reach it. Bridged mode is completely different. It connects the VM's virtual network card directly to your real Wi-Fi adapter so the VM shows up on your home network like any other device. If you leave this on NAT, Active Directory will silently fail a few steps later with errors that don't point you back to the real problem. So, bridge mode is non-negotiable. The slide has the exact steps, and once storage and network both look right, it's time to boot it up and install Windows Server. The slide above walks through the entire install wizard, but the one decision that actually matters is choosing Standard Desktop Experience. That gives you the full GUI with Server Manager and all of the admin consoles. Server Core is just a command line, which is great in production, but not ideal when you're learning. You'll set an administrator password at the end, and that's your keys to the kingdom at that point. Once you're logged in and looking at the Server Manager dashboard, the first thing we need to do is give this machine a proper name. Windows generates a random computer name by default, something like win blah 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 blah. And that's useless when you're managing infrastructure. We rename it to DC01, Domain Controller Number 1, because in real environments with dozens of servers, the name is how you know what each machine does at a glance. Sometimes you see like FS01 for a file server or WEB01 for a web server. The slide has the steps. It's a pretty quick change in a reboot. Once it comes back up and you confirm the name change in Server Manager, we need to make our networking a little bit more tight and lock it in. Now, first you verify that bridge networking is doing the job by running ipconfig on the VM. The IP address should be in your home network range, so if you see 10.0.2 instead, you're probably still on NAT. And you'll need to go back and fix the VirtualBox settings. Then, once you confirm that, from your host laptop, you'll ping the static IP you picked just to make sure nothing else is using it. If the ping times out, then that means that the address is free and it is yours. If something responds, just pick a different number. Once you've confirmed that the network is healthy and the IP is available, it's time for the most critical configuration setup in the entire lab. You assign the static IP so the server's address never changes because everything on the network needs to find something reliably. But the piece that kind of trips up almost everyone is the DNS. You set the preferred DNS server to the domain controller's own IP, which kind of feels circular, but here's why it has to be that way. When you create the domain, Active Directory registers a bunch of records in DNS that say, I'm a domain controller, I live here, I provide these services. But if DNS is pointed at your router, those records go nowhere because your router knows nothing about Active Directory. The DC has to be its own DNS server so it can find its own records. This one misconfiguration is behind the majority of my EV lab doesn't work posts that you will find on any Reddit. The slide has exact values to enter. Once everything is filled in, we verify it all in the next step. Now what we're going to do is run IP \all and check 3 lines, your static IP, your gateway, and most importantly, your DNS server showing the DC's own IP, not your router, not 127.0.0.1, the actual IP of this machine. And I'm being repetitive about this on purpose. If DNS goes wrong here, then after this point, it either fails or gives you misleading errors. So don't move past a step until all of 3 of these are right. With networking completely solid, we can finally move to installing Active Directory. You're adding the Active Directory domain services role through Server Manager, which is essentially telling the server your job is to be the central identity and authority for this network. Windows Server is kind of modular like that, so out of the box it doesn't do much. You will add the capabilities by installing roles. The wizard is pretty straightforward, it's all on the slide. When it finishes, you'll see a yellow flag like notification in Server Manager, and that's not an error, that's like you're prompting to move on to the next step, which is creating the domain. Now, when you click that yellow flag and promote the server to a domain controller by creating a new forest with root domain lab.local, a forest is the top level of the directory organization. And for a home lab, one forest with one domain is pretty much all we need. You'll set a DSRM recovery password, click through a DNS delegation warning, totally expected, and then let it install and reboot. After it comes back, the login screen should change to lab/administrator. That domain prefix is how you know the domain is live and DC01 is running it. But right now, our DNS server only knows about lab.local and can't resolve anything on the internet. So we need to fix that. You set a DNS forwarder pointed at your router so that internal names like dc01.lab.local get resolved locally on the DC. And everything else like google.com gets forwarded to your router and out to the internet. You verify with nslookup google.com, and if you get an IP back, your entire DNS chain is working from end to end. This is the same split DNS setup that real corporate networks run, just in a miniature format. And with the entire infrastructure in place, we can finally get into the reason we built all of this identity management. Now, you start in Active Directory users and computers by creating two organizational units under lab.local, one called users and one called groups. OUs are like folders for your directory. The reason we create custom ones instead of using the defaults is that the built-in users container isn't actually an OU, meaning you can't apply group policy to it. Custom OUs are what give you that ability from day one, which is the best practice to follow in really any environment. With that structure in place, we start populating it. You are going to create the two security groups in the OU, HR team, and IT help desk, with two user accounts, J Doe and A Smith. The slide will walk through every field, but the concept behind this pretty much is what matters. In identity and access management, there is a principle called role-based access control. You never assign permissions directly to a person. You assign them to a group that represents a role, and then you put the people in the group. So when someone changes a job, you move them between groups instead of touching every individual permission. That scales from our two-user lab to organizations with hundreds of thousands of employees. Now to put that principle in practice. You're going to add J Doe to the HR team and A Smith to the help desk. The clicks are simple, they're on the slide, but when you build, it's the core of the IAM, an identity linked to a role. Every enterprise system, Active Directory, Okta, Azure, they all work on this exact principle. And in an interview, when someone asks, how do you manage access for a new employee? The answer is, I add them to the appropriate security groups and they inherit the access their role requires. That's what happens here. Now we just need to lock down the security baseline. You edit the default domain policy and group policy management and set minimum password length to 12 with complexity enabled. What makes this powerful is that you set it once in one place and every user in the domain is automatically held to those rules. The domain controller enforces it, nobody gets around it. That is centralized security policy, and it's one of the biggest reasons organizations run Active Directory. With that in place, let's verify everything we've built. So you can confirm everything basically in PowerShell. You do the get user AD John Doe blah 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 blah, and that is going to be storing user objects. You do the members, provides the roles are in place. These are basically the same commands you'd run in any real environment to audit access. And you're also going to be learning to verify through the command line using this stuff because clicking through the GUI is what separates somebody who's learning from somebody who's practicing like a professional. Basically, this next slide is just going to give you the full checklist to make sure nothing got missed. Checklist. So this slide has 12 items covering everything from your static IP to your group memberships to your password policy. Walk through each one. If anything is off, the slide numbers throughout the presentation tell you exactly where to go back to and fix it. But if everything checks out, take a second to think about what you actually built, feel a little accomplished. You took basically an empty virtual machine and turned it into a centralized identity authority that authenticates users, assigns roles, resolves DNS, and enforces security policy. Congrats. And this architecture is identical to pretty much what companies run at scale. It's just miniature. And this is a wrap. All right. A wrap on part one, hopefully, if people like this. I know that I moved this a lot faster than what would normally happen in videos like this, and I didn't really show like my screen, but that was really because of the recording situation. So this full presentation with every click and link spelled out is going to be in the description. Pull it up, do the lab on your own, and if you have hands-on experience with Active Directory and you want to contribute to doing more projects, I suggest going to Professor Messer or a couple of the things that I might have linked below in terms of finding things to do. Um, but perhaps when we do a part two, my screen recording will actually work, and I can show you how to add a Windows client VM, join it to the domain, log in as a domain user, and really kind of show you how all of this comes together with the user experience. Now, thank you guys for watching, and I hope to see you in the next one.